Hello everyone, I am Anitha Krupanidhi, Assistant Professor of Chemistry at Marri Reddy Institute of Technology and Management. Today we'll discuss about one more topic from Polymeric Materials chapter, that is natural rubber. In our daily life we are using various types of rubbers, right? So we cannot imagine a tire without rubber. Right. So today we'll see what is this rubber, how this rubber is prepared, what are the applications, what are the different types of rubbers. Now we will see. Okay. Yes. In today's session, we'll see about these are the topics, that is rubber, a small introduction to the rubber and the definition, and next one, what is meant by a natural rubber. Okay, so this topic we will discuss, and next what is meant by vulcanization of rubber and why we are doing the vulcanization. Okay, that also we will see now. And next, one more type of rubber we will discuss today, that is elastomers. Elastomers means these are nothing but man-made rubbers. These are synthesized rubbers. For that example, bunized rubber we will discuss today. So now we will see. So first we'll see what a small introduction to the rubber. So this rubber is a natural product. So this rubber is a natural product which is obtained from the tree. Right, so from the tree means here in the picture we can see it is a rubber tree. Like this large number of trees will be there. To that tree, a small V cut will be made on the bark of the tree. Okay, so on the tree a small cut is made, and then afterwards a cup is arranged. A cup is arranged, and next from that cut, what we have made from that cut, a milky white fluid comes out from the tree, that is collected in a cup. Okay, so here we are observing this white liquid, a semi-solid liquid we are observing here. It is called as latex. So this liquid is called as a latex. Clear? So it is named as latex, which is obtained from the plant. This collected latex, after collecting this latex, then it is washed. It is washed, filtered, and it is reacted with a few acids to conceal the rubber particles. Okay. So to conceal the rubber particles means it is in liquid nature, just to become a semi-solid. It is reacted with few acids. Okay, so now today we obtain 99% of the natural rubber from a tree called Hevea brasiliensis. This is a rubber tree, Hevea brasiliensis. So there are many rubber products which we come across in our daily life, like rubber gloves, rubber bands, and then rubber footwear. And then next, still there are a few modifications in the rubber to get a more durable rubber, that is called as vulcanized rubber. With those modifications, we are using for the preparation of tires for the vehicles. Okay. Now we'll see what is the definition of rubber. So this rubber is, and what is meant by rubber? It is nothing but it shows a property called as elasticity. Okay, so it is an elastic substance that can be obtained. It is an elastic substance that can be obtained either naturally or artificially. Right. So either naturally means it is obtained from the plant in the form of a latex, that is called as a natural rubber. Artificially means we prepare that rubber. We prepare a rubber in the laboratory, that is called as a artificial rubber or synthesized rubber, or the elastomers. Okay. So artificial rubbers, these are chemically synthesized in the laboratories. These rubber items have the ability to recover their shapes after being stretched or distorted. Okay, so that means when we apply a pressure to the rubber, it will be elongated, and when we release the pressure, again it comes back to the original position. Right? So it is called as a stretching and or distorted. So when we stretch or when we release the pressure, this rubber come to the normal position. Okay, so the elasticity. So we are telling that rubber has the property of elasticity. That's why we are using in for various purposes. But here, how this elasticity comes to the rubber? Okay, so what is the main reason for this elasticity of rubber is it has the coiled helix structure. Due to the presence of a chemical structure in the rubber, that is called as coiled helix structure. Okay, so what is this coiled helix structure means? This is the total structure of natural rubber. Because of the presence of this chemical structure, rubber has the property of elasticity. It shows the property of elasticity. Now we'll see this natural rubber, it originates from a rubber tree that is called as Hevea brasiliensis. The main composition is the polyisoprene. This point is very important. We have to remember the composition of main natural rubber is polyisoprene. How this polyisoprene is formed means, so in the previous slide we have discussed that rubber, how this rubber is obtained in the form of a latex. Okay, so that latex is nothing but, what is the chemical compound present in the latex is, that is nothing but the isoprene. Clear? So this is nothing but the isoprene. Isoprene is nothing but its IUPAC name is 2-methyl 1,3-butadiene. Okay, 2-methyl 1,3-butadiene, and here 2-methyl, first carbon, third carbon is having the double bond, so that's why it is called as 2-methyl 1,3-butadiene. So what is this isoprene? Where this isoprene structure is present? Where it is present? So it is present in the latex. Okay, what the liquid, a milky white liquid we have collected from their plant, that is Hevea brasiliensis, that latex contains the structure that is the isoprene. Okay, after taking that latex, it undergoes polymerization. Okay, after polymerization, that means it is subjected to heat and pressure. So when we apply heat and pressure, some change occurs in the chemical structure of the isoprene. Okay, so change occurs in the chemical structure of the isoprene when we apply heat and pressure. Okay, so when we apply heat and pressure, what happens is this pi electron, so double bond is there means, here it is double bond is there means one is sigma bond, another one is the pi bond. We all know this one. So this pi bond, it is a weak bond, so it shares the electrons. So because of this heat and pressure, when we apply here, bond is nothing but what, students? Bond is nothing but 2 electrons, right? So bond is nothing but 2 electrons. This one electron is shared to this carbon, and another electron is shared to this carbon. Okay, and next one, here also we have one more pi bond, then this pi electron, it is shared to this carbon, and this pi electron shares to this carbon. Okay, following? So here, because of these two bonds, it shared the electrons, this carbon will get a bond here. Here electron is there. By taking these two electrons, here a bond is formed. Okay, so next, by using this single electron here in continuation with this carbon, it forms the one more bond because it is a polymer. Okay, so now we can see here in this place we are getting the bond here because of the sharing of the pi electrons from the adjacent carbons. So here we will get the bond here, and here bond, because it is a polymer, here bond is there and then taken n times. Clear? So now it is called as polyisoprene. So isoprene is subjected to polymerization by applying heat and pressure. Then afterwards we will get the product that is the polyisoprene. Okay, so now this polyisoprene is nothing but the natural rubber. Clear? So this isoprene is this composition is from the latex. So that latex, after taking latex, we are subjecting to the heat and pressure. It undergoes polymerization, and next the structure isoprene changes to polyisoprene, which is nothing but the natural rubber. Clear? Yes. Now we'll see this rubber. So in this natural rubber, just now we saw that is isoprene converts to polyisoprene. This is somewhat it is very smooth in nature. So smooth rubbers we can't use for all purposes, right? So to get more durable rubber, or some tensile strength should be there. Tensile strength means when we stretch the rubber, how much it will be to some extent only, but how much we stretch the rubber, that much it should be strong. So that is called as a tensile strength. So to improve the properties of the rubber, we are doing we are adding a few additives to the rubber. Okay, so in those additives, the main one is the sulfur. It is most widely used. So rubber, when it is immersed in sulfur, or when sulfur is added to the rubber, we will get more durable rubber, which is nothing but a vulcanized rubber. Okay, so just after getting a natural rubber, from isoprene, immediately that natural rubber we cannot use for all purposes in our daily life. Okay, so to get the different uses of rubber, different properties in the rubber, this rubber is again, it is sulfur is added. Okay, so some modifications will be done to the rubber. In that, the sulfur is added to the rubber. When sulfur is added to the rubber, then that process is called as vulcanization. Okay, so this is also a very important topic to you. It is called as a vulcanized rubber. So after vulcanization, what the rubber we get, that is called as a vulcanized rubber. So the rubber, first it is immersed in sulfur and additive filled solution. It is an additive filled solution, and sulfur is the main component that promotes vulcanization. Okay, so sulfur is the main component that promotes vulcanization. And next, what are the in this vulcanized rubber, the mechanical properties like tensile strength, elasticity, and the abrasion resistance of natural rubber can be improved. Okay, so it can be improved. So there is an improvement will be there in the vulcanized rubber. So that's why we are doing the vulcanization. So now we'll see what is when we do vulcanization, what changes occurs in the natural rubber. And next, and what is the reaction takes place, what is the chemical change in chemical structure takes place. Now we will see. So here in this vulcanization of rubber, so what is meant by vulcanization we have already discussed, right? So before vulcanization, this rubber has the, like this, all the linear chains are there. When we add sulfur to the rubber, then what happens, between the two polymeric chains, it develops the cross links. Okay, so between the two polymer chains, it develops the cross links. So because of these cross links, that rubber will be durable and it will be strong. Okay, so here it is. Now we can see here it is the difference. We can see first one, it is the rubber. This is the natural rubber. We have added sulfur, and between the two polymeric chains, it develops the cross links. Right? So it is the vulcanized rubber. So sulfur is the vulcanization agent for natural rubber, but few more other chemicals are also used, like additives along with sulfur. Now we'll see what is the chemical reaction takes place, or the chemical modification takes place when we add sulfur to the rubber. So here natural rubber means what is the structure, students? In here we have discussed isoprene converts to polyisoprene, right? That is the natural rubber. That natural rubber now we are taking, here it is a methyl group and then polyisoprene it is. In this polyisoprene, there are 2 units of polyisoprene are there. We are adding the sulfur. It is a natural rubber. To this natural rubber, we are adding the sulfur. When we add sulfur to the rubber, what change occurs in the chemical reaction? So these sulfur, it gets attached to the polymeric chain of the rubber, natural rubber, where it attached, not the entire chain. Okay, so not the entire chain, where the double bond is there in the structure. Okay, so where the double bond is there in the structure, here if you observe this structure where the double bond is there, this carbon is called, this site is called as double bonded site, right? And here this one, and here also here, and this one. So where the double bond is there in the natural rubber, at the site of double bond, this sulfur, it go and attaches to the, it forms a linkage. Okay, it forms a link between the two polymeric chains. Now here you can observe, in this place double bond is there. That's why here in the place of the double bond, a sulfur link is there here. Here also sulfur, here also sulfur. Okay, have you observed here? So where the double bond is there, that at the doubly bonded site, this sulfur, it forms a cross link. It forms a cross link. Okay, so now these are the sulfur cross links. Now this with the sulfur cross links, this rubber is called as what? It is a vulcanized rubber. Okay, now it is this type of rubber, it is named as vulcanized rubber. Now we'll see what are the advantages of this main vulcanization. So in this, because of this vulcanization, it brings excellent changes in the properties of the rubber. Okay, so this vulcanized rubber has low water absorption tendency, higher resistance to oxidation. Okay, this vulcanized rubber, it has the high resistance to oxidation. It has high stiffness. It has good durability, and it is resistant to changing temperatures. So based on the seasons, temperature also changes. That rubber has to withstand the temperature. Okay, so that's why this vulcanized rubber, it is very good resistant to changing temperature, and it is resistant to swelling in organic solvents. Okay, so this is about the natural rubber. Now we'll see one more rubber, that is elastomers, which is nothing but the synthesized rubber. So rubber can be obtained either naturally from the plants, or it can be synthesized in the laboratory by using chemicals, right? So those are called as, that synthesized rubber or man-made rubber is named as elastomers. These elastomers also, these are the flexible polymers. It can be, these elastomers also can be deformed and return to their original shape once the stress is removed. Okay, so these elastomers have the covalent bonds between the polymer chain in the form of a cross links. Here we are observing the polymeric chain. Here somewhat yellow is there, it is not visible properly. These are the cross links. So between the polymeric chain, that means the linear chains, there are covalent bonds present here. It enables the elastomer to return to its original shape after being deformed. Okay, these are called as elastomers. For these elastomers, we will discuss one example in your syllabus, from your syllabus, that is called as Bunaeus rubber. Okay, it is an elastomer. Elastomer means it is synthesized in the laboratory. So how this Bunaeus rubber can be prepared or synthesized in the laboratory, now we will see. So what is meant by a Bunaeus? It is also called as styrene butadiene rubber or GRS rubber, government recognized styrene rubber. So how this elastomer or the Bunaeus rubber can be prepared? By following a method called as polymerization. That polymerization also, it is, the type of polymerization is copolymerization. Okay, so what is meant by copolymerization? In the previous videos we have discussed what is meant by polymerization, what are the different types. So here what is meant by a copolymerization means there are two or more different monomers will be present. So in a polymer, how a polymer is formed, students? It is a combination of the monomers, right? So two or more monomers will be present, and those monomers, they may be same or the different. Okay, so here two or more monomers, that also different monomers will be present in the polymer chain, or different monomers we take for polymerization, that is called as copolymerization. Okay, so different monomers, we take different monomers, and these are allowed to polymerize together to form a product. Here two different monomers we are taking. What are those monomers we are taking for the preparation of this Bunaeus rubber? So example is for this copolymerization, example is the Bunaeus rubber. It is a copolymerization of butadiene and styrene. Now we'll see how the reaction takes place. What is meant by this Bunaeus? So Bunaeus means it is a copolymer because we are taking two different monomers. It's what is meant by Bu? Bunaeus, how it is named, how the name is given. So Bu stands for, Bu means it is nothing but butadiene. Okay, so it is nothing but butadiene. And next Na means sodium. Na means it stands for sodium, and this S, a capital S we have written, this S is called as styrene. Okay, so this S is called as one styrene polymer we will take, and then butadiene monomer we will take in the presence of a catalyst that is called as a sodium. Okay, so now here it is butadiene and styrene, these two different, one and then two. These two different monomers we will take for this polymerization. So it is formed by the copolymerization of butadiene and styrene. It is prepared by the 1,3-butadiene 75% and styrene will be 25% with the sodium. Now we will see the chemical reaction. So styrene reacts with styrene. This is a polymer and it is a benzene ring with CH double bond CH2. It is called as styrene. It is called as styrene. This styrene plus and butadiene, styrene plus butadiene, and here in presence of sodium. Now here it double bond during this reaction in the presence of a catalyst. And heat is applied. This is called, in this polymerization reaction, a double bond breaks. It gives that pi electron gives electrons to the adjacent carbon. Now here also the same phenomena previous I have explained. Here pi electron is there. Pi electron means a bond, means it is nothing but which contains the 2 electrons, right? So here also 2 electrons. Now this bond, it shares electron to this carbon and this electron is shared to this carbon. Okay, so by using these 2 electrons it forms a bond here. That's why in this place double bond comes, and these two will be single bond, and remaining this single electron, it will be formed as a bond with the adjacent carbon because it is a polymer. Okay, yes. Now here we can see, we can observe the mechanism. Same mechanism takes place like this. In this place double bond comes and here also single bond. This is a butadiene styrene copolymer. This is called as bunized rubber. Butadiene styrene copolymer. Why it is called as copolymer? Because we have used the 2 different monomers. Now we'll see the properties and applications of this bunized rubber. It has high abrasion resistant, high load bearing capacity. It is easily oxidized in the presence of ozone, and it swells in oils and organic solvent. This kind of rubber, when we keep this rubber in the oils or organic solvents for a long duration, it swells. Its vulcanization is similar to that of a natural rubber. Now for this bunized rubber also we can do vulcanization because of the presence of that double bond in the structure. Okay, when we add sulfur to the butadiene, this again where the double bond is there, at that place sulfur linkages will be developed. Okay, so this bunized rubber also can be vulcanized. What are the applications? It is used mainly for the manufacture of tires. It is used for floor tiles, shoe soles, gaskets, wire, tank linings, etc. So these are the few references for this topic. In this session, we have discussed about what is meant by a natural rubber, how it is obtained, and then what are the types of rubber, natural rubber and synthetic rubber, that is man-made rubber, and next what is meant by a vulcanization process. In this session, we have discussed all these topics. These are the few references for this topic. I hope this video is helpful to you. Thank you.